Hello and welcome to another one of these ADD videos. Today we're going to be looking at normal distributions. More specifically, we're going to be looking at how to use the z-score formula. Because the normal distributions deal with everything from height, weight, grades, free throw shots, these all have different scales and different units of measure. So z-score is a way to standardize it in terms of the standard deviation. So basically what you do is you plug in your data point in here, whatever the question is asking, right? So x is less than or greater than some number will always be part of the question, that number goes there. This is your population mean, and this is your population standard deviation. I'm not going to do the one below, I'll save that for the next video. So what are the steps? You got to plug your raw score and your population standard deviation mean into your formula for z-score. Get a z-score and convert that to a p-value, and that's a proportion less than your data. And I'm going to pull up a z-score right here. Oh, no, that's Facebook. See, where did I put my z-score? Where did you go? Z-score. Here you are. So if we have z's are going this way and that way, and we're converting them to the p-values or the proportions inside the table. So basically, if you are asked to find a value that's less than, just use the table value. If it's greater than, do 1 minus the table valet, the spelling there. That's what happens when you make late night videos. And then if it's between two numbers, just find the less than, or for both the numbers, and take the difference between the two. Actually, that should be less than. Alright, let's see it in action. So let's say we have a normal distribution again, same as before. 82 is the population value, 6 is the standard deviation. But now, instead of being exactly 1 or 2 standard deviations above or below the mean, we look at the data point of 85, which is half a standard deviation, but you can't really go on that. So what you gotta do is you gotta plug in 85, your data point, minus your mean over your standard deviation, and then you pull out your calculator, find mine. Actually, you don't need that, do you? See, that's what happens when you can calculate independent. 3 over 6 is 1 over 2, so we're looking for a z-score of 0.5. That is your z-score right here. The z-score? No, it's the z-score. And let's see. Let's convert that into a. No, don't need the time for that one. We need this. So we have a z-score of 0.50. So we go here. Let's do the point right there. Okay. Right, so that means there's 0.6915 of the class below it. Right, great. So let's see. So we will plug into the formula z equals x minus mu over sigma. We got a z-score of 0.5, and the proportion below, we looked it up on the table, was 0.6915. And if I wanted to do greater than or equal to 85, that would be 1 minus 0.6. Let's do it on the calculator. 0.3085. Okay, so there's two of the main calculations you'll be asked to do. One right there. And this one right here with the greater than. Okay, so let's say we also get another grade of a 75. And 75 is not exactly 1 or 2 standard deviations away from the mean. So let's see if we can find the proportion of the derivatives between 75 and 85. So what we need to do for this is we need to first learn how to draw an arrow. We need to do find less than 85, and then we need to find less than 75, and then do this number minus that number. Again, conceptually, the way it looks is like this. So 85 would be here, 75 would be there, and the mean is a little bit closer here to 85. Alright? So what we're going to do is we're going to try to find the area in between those two lines, and highlight that for you. Okay, so let's do it. We actually got the first number already. That's going to be 0.6915. So all we really need to do is the second number. So the second number is going to be 75. So the probability of x being less than or equal to 75 is going to equal to 75 minus 82 over 6, which gives me a negative 7 over 6. And when we do that, it's a 1 to 1/6, which when we do that one, my mind's already calculated, we get negative 1.166 with repeating sixes. So what you got to do there is just make that a 6, or make that 6 a 7, sorry. Because the z-score table is only limited to 2 digits. So then we go to our z-score table. Where'd it go? Z-score table, there you are. So we had negative 1.17, so negative 1. Now be careful, because here on the negative side it's 0.9, real close. Oh, 9, sorry. But on the positive side it's 0. So make sure you don't fall for that little blunder. A lot of people do. And they wait till the test to start studying. Negative 1.17 it was, so that'd be the second grade column. So that would be this value right here. So that's about amount less than. This is what happens when you record videos at 2 o'clock in the morning, or actually it's not quite that late, it's about 1 o'clock I think. 0.120, that's what it was. So 0.120. What that 0.120 signifies is that little sliver less than. Divided like that, the color made it hard to visualize, and these things need to quit popping up. Now let's undo that. Just as when you do it, there you go, finally. Let's do a different shade. Now you can see what we're talking about. There we go. Now, if I put the 0.1210 that I just shaded in and I subtract the 2, I'm going to get, let's see, 0.695 minus 0.1210 equals 0.5705 would be, I guess I should write it in yellow, the yellow region, that's right there. That matters. In between. So we found both and took the difference. Alright, so recap. If we want less than, plug in your data point, plug in your mean, your standard deviation. And simplify it, that's your z-score. And then for less than, look up that z-score, and it's the table value for less than. And then for greater than, it's one minus the table value. And then for in between, you just take the difference. Alright? So I hope this example clarified things for you. You can use the empirical rule to get a rough idea to see if your data is correct. For instance, this is about half a standard deviation away, whereas this is a little bit more than one standard deviation away. So roughly under one standard deviation and one standard deviation above and below had 68% of the data, and this has 57% of the data in between. So that's roughly right. Okay, so try to use that empirical rule to help check your work. Alright, thank you. Practice, 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 and have a nice day.